Telecommunication forms the backbone of modern society. From the millennia-old smoke signals to the revolutionary telegraph, the invention of smartphone to modern-day smartphones, the smart cities of the future, mankind has always been driven by a passion to connect, communicate, and collaborate. These advancements has not only changed the way we share information and emotion, but also society as a whole. As we stand on the brink of IoT and 6G, I am sure today's guest can give us a brief glimpse into the promising future. Good evening, everyone. I take great pleasure in welcoming you all to this guest lecture from Probe, featuring a leader and innovator in the telecommunication industry, the Vice President and Head of R&D of Samsung India, Mr. Amit Mannan. With decades of experience in research and development, Mr. Mannan has led groundbreaking projects, particularly in wireless telecommunication, such as in 6G research, 5G deployment, and next-generation wireless networks. Under his leadership, Samsung's R&D center in Bangalore has become one of the largest and most prestigious global hubs for technology and innovation. We are eager to learn from you today, sir, and we look forward to gaining insights from such a visionary with decades of experience in this rapidly developing field. So, without further ado, ladies and gentlemen, Mr. Amit Mannan.
Thanks a lot for the introduction. A real privilege to be part of Probe. Always a pleasure to interact with the best and brightest young minds in the country. So today I am going to talk to you about 6G, the hyper-connected future. And just a disclaimer before we start, I am by no means an expert on 6G. My work is mostly in solving the current problems we have. However, after several decades of experience and having seen telecommunication evolve from 2G till 5G until now, I'm surely very curious to know how 6G will look like, um, and that's basically something that's going to keep us all interested in the coming years. So I'd like to get into it. Before we talk about 6G, let's first understand how is 5G doing as a mainstream technology. So I hope you can see my next slide. Just confirm if the slide is progressing. Anyone?
So we can see the slide next slide.
Okay, good. So 5G has been around now globally for almost 5 years, or maybe a little more than 5 if you count the pre-standard deployments as well. 343 operators already launched, fully 3GPP compliant 5G, and the subscriptions have already crossed 1.7 billion. And actually 5G has been the fastest to reach 1 billion subscriptions. It took just 3 years for 5G to cross that. Just for comparison, 3G took 10 years and 4G took a little lesser than that. Just for reference, overall number of subscribers in the mobile telecommunication world is currently at 8.5 billion, out of which 1.7 billion are 5G already. And of course, the dominant technology is still 4G with 5.2 billion. So, 5G has picked up. Maybe some of us who are, hardcore into the sector are a little disappointed by its success. We were hoping for much more success. Nevertheless, it is here and it will continue to grow and develop. Now let's look at some of the lessons we learned from the 5G journey. I will specifically talk about 5G R&D from the Samsung perspective. We have been focusing on 5G technology since 2009. So that means basically it's been a 10-year journey until the launch. So the big lesson from 5G is that we need to start early. So we have conducted various 5G trials, and finally in October 2018 was when the big telecom operator in the US, Verizon, commercialized the world's first 5G home broadband service on the 28 gigahertz spectrum. And carrying it on the same year, in December, in South Korea, we launched the first kind of B2B enterprise deployment of 5G. And then finally, the full user commercial version of 5G was rolled out again in Korea in 2019. This is world's first, by the way. And by 2020, it had also been launched in Japan. So these are the three markets where usually telecommunication technology first hits, right? Korea, Japan, and the United States. So, yeah, I think what we understood when we launched 5G was that you need a full decade's preparation as you make a generational shift. Now, as we start thinking about 6G, which is still some years away, it is good to look at some of the mega trends while moving towards 6G. So the first one is, of course, that the machines are expected to be the main users. Um, by 2030, you may have 8.7 billion people, but you may have well over 500 billion machines all connected, right? So this would include everything. I mean, from vehicles, robots, home appliances. So machines are going to be the driver as far as 6G is concerned. And we will find new form factors emerging. I think already you would have heard about AR glass launches by Apple and recently by Samsung. In fact, only yesterday. Uh, we have heard about prototype VR headsets, those big devices you put on your head. And there have been some initial hologram devices also. So all these will slowly develop as we move towards 6G. I think the important point to note is that machines do not have are not limited by some of the constraints which regulate humans, right? In terms of latency perception or audible frequency or visible wavelength. So the limit of machines is actually not defined. So that's why I think 6G maps perfectly to the machines. The second mega trend is, of course, something I'm sure all of you like, which I'm still trying to understand, but it's ever growing concept that is radicalizing the technology world, and that's AI. And specifically for telecom and specifically for radio access networks or RAN, it can be a game changer. So we already see, if you look at the right side of this slide, what we call as AI for RAN. These are more like AI tools to improve the performance and efficiency of the current radio access networks. These have been around for a while already. Um, they basically aim to enhance the experience coming out of the RAN. Then we have AI on RAN, which is basically development, deployment of AI-enabled applications at the edge of a network that can be delivered over 5G connections, right? So this is where we are right now. This space is currently growing for 5G networks or has started to grow. But what we are really looking at is AI and RAN, wherein AI and RAN share the same infrastructure. So until now, the AI applications that are enabled by RAN are usually running separately. Yeah, they're running on your big GPUs, your NVIDIA powered servers, and so on, right? But eventually, we expect AI and RAN to share the same infrastructure. So the AI and RAN processes get integrated so that resources are constantly being used, even there when there is no mobile customer activity in the network, right? So optimal usage of hardware resources. And also important to note some of the key focus areas of AI in telecommunications at present, or as they say, AI in wireless, right? So whether you want to deploy a network, so you want to optimally position a base station uh, in a certain section of population where you have limited coverage, or whether you want to monitor the KPIs uh, and performance of a network, you want to predict when a fault might occur in a network. Both of these can be, effectively accomplished using AI. Essentially, AI, is utilized as optimization through concepts of network slicing and orchestration. So that's another big area which AI is impacting as far as telecom is concerned, and will continue to grow as we move towards 6G. The next mega trend I'd like to talk about or touch upon is openness. So you know that the telecom infrastructure business was for many, many years based on, proprietary cutting edge kind of hardware boxes, which each of the vendors, be it an Ericsson, Nokia, Samsung, used to sell to the telecom operators. However, I think the telecom operators started becoming smarter some years ago, and they wanted to have the flexibility to run our telecom solutions on general purpose CPUs and GPUs. So as the CPUs and GPUs evolved, so there became a need to completely have software-based implementation away from any proprietary kind of hardware. And another very important aspect is the increased utilization of open source based software. This is something which I'm sure as undergrad or postgrad students, you may have already got your hands into or would like to research, is how to build smaller network software components purely based on open source software, right? Software which is completely open in the sense you can plug and play from different companies, different vendors to build a full network. Um, there are communities like ORAN, which essentially focus on front haul. Front haul is between the digital unit and radio unit, right? And ORAN also dictates the control interface, which is a link to all your apps and controlling kind of applications which are powered by AI and ML, right? And then there are also other open source communities apart from ORAN, like Nefio and HONAP, which essentially give you an automation framework to manage your network. So these are just a couple of big open source communities which are gaining prominence. And as we move towards 6G, they will become increasingly important. The next one is social goals. So communication technology and its infrastructure are increasingly contributing to address social issues. Now, listed here are the 17 UN Sustainable Development Goals. I'm not claiming that our industry will address all 17 of them, but at least some basic ones. Like the most obvious one is, energy and power saving, or greenhouse gas reduction, reducing carbon footprint. So using equipment that does not pollute the environment, that is more energy efficient, or even, providing connectivity to the remotest part of the geography, so that everybody can have access to information and therefore education as well. So these are some of the social impacts which the telecommunication industry is having. Now, why I'm talking about it in the 6G context is while designing 6G, these aspects will be kept in mind right from the beginning, right? So that we keep all these sustainable development goals in mind while we design the network for the future. So that brings us to the foundation for the hyper-connected world. Basically, a summary of what we have been discussing. It will use AI as the building block to improve performance, reduce energy consumption, self-healing, evolving networks, giving you personalized quality of experience. These networks will definitely be open and they will be fully compatible with general purpose processing units. They will use open source extensively, and it'll be a level playing ground for new entrants as well. So probably break the monopoly of two, three, four companies who currently rule the telecom world, and a lot of other players would also get in. And finally, the social goal aspect, which I already touched upon, that's going to be a key foundation principle for the hyperconnected world. How would the 6G era look like? So we are maybe 6, 7, 8 years away from it. But yeah, we have some ideas what it might look like. So I'm sure you guys have heard about concepts like digital twin, right? So digital twin is kind of a digital replica of any component or object or complete system. And you know why 6G makes sense in conjunction with digital twin is because you need that kind of um, you know transport capability. Yeah. So just to duplicate 1 square meter of area, you require up to 1 terapixel, and this might actually require zero point 0.8 Tbps of sync rates. Currently, these are not easily possible by our mobile networks. Maybe some fixed wireless or uh, Wi-Fi networks may come close, but typical mobile networks cannot give this kind of speed. So I think in the 6G era, you will see a lot of action with digital twins. Another area is, of course, high fidelity holograms. Of course, all of us have seen those iconic, sci-fi movies like Star Wars or Star Trek, right? And you may remember, uh, people popping out of gadgets, or at least their holograms popping out of gadgets, right? So that indeed will become a reality. I think a couple of years back already, South Korea Telecom demonstrated that a 1 centimeter cube hologram requires up to 1 gigabyte. So if you want a 6.1-inch display kind of hologram, it requires more than 2 terabytes. So that's the kind of data requirements we are looking at. And of course, AR, VR, we already know is here. And to realize its true potential, it will require much higher data rates. And of course, it's something to think about, what the form of the new mobile phone will be in the 6G era. We don't know. It could be, full of holograms. It could maybe be your TV, even your car screen. Sky's the limit. So we can dream. Yeah. All right. So this is the 6G vision as detailed in the IMT 2030. Just FYI, the IMT 2020 was the 5G detailing of the usage and capabilities of 6G. So there are, of course, the guiding principles of connecting the unconnected, ubiquitous intelligence, sustainability, security, privacy, and resilience. And I think each of these have certain KPIs or parameters associated with it, right? So, for instance, the latency of 1 millisecond in 5G is expected to become 1/10. Mobility can exceed or double the 5G capability, which was 500 kilometers per hour. In fact, implementing mobility in telecommunication is one of the most challenging things. High speed rate handover. So imagine you're going at a very high speed and your calls are getting handed over from one base station to the other. That's in fact one of the most challenging things to do. So 6G surely will make it possible for this to happen, maybe even in a jet traveling at speed of sound. Yeah. So these are some of the details, but okay, we don't need to get into that. But what I'm trying to get at is there is already a vision, a clear vision set aside by ITU and some guiding principles that will help us define 6G as we move along. Now, let's also look at some of the, you know, um, architecture considerations when we are designing 6G systems. So the three native principles, I think, are going to regulate the design. So cloud native, green native, and AI native. I think cloud native is a design principle that should be considered while designing next generation infrastructure so that it can flexibly respond to rapidly changing requirements to achieve high availability, scalability, and operational cost by providing communication services on cloud technology, right? So we all know clouds very much here. So I think 6G will definitely be driven by cloud native principles. Green native is another interesting design principle. So it needs to, I mean, it's important that we ensure the sustainability of the mobile communication business uh, is uh, is considered right at the start, like reducing carbon emissions and to make sure that we do not do anything to speeden up climate change globally, right? So that topic will be considered right up front while designing the network. And of course, AI native, we've already been discussing. Yeah. So it's important that AI needs to be integrated in all layers of the network. Yeah. So I think we can also look at how the RAN architecture has been evolving. So if in the past it was simply RAN software sitting on purpose-built hardware, like I already mentioned, proprietary or purpose-built hardware. Today we have already evolved to vRAN or virtual RAN, which is sitting on your you know common hardware platforms. Um, Even now, I would say only about 5 to 10% of RAN revenue comes from virtualized RAN. So that will grow. And eventually, like I said, we will have, apart from the virtualization of RAN, we will have AI also sitting on the same general purpose hardware. Only thing it's instead of just CPUs, we'll have GPUs as well. And maybe even some of the core network functionality like the gateway sitting on the same platform. So these are some of the 6G architecture considerations. Now let's talk about some of the candidate technologies. Yeah, there are many, and there is active research going on in many of these. I have just listed some of them here on the screen. So I don't think we have time to discuss all of them, but I would like to specifically talk about four of these technologies. The first one is the convergence of the communication and computing worlds, and specifically the evolution or importance of split computing. I think split computing is going to be very important in 6G era. Comprehensive AI. So I've been talking about AI continuously, but what does comprehensive AI actually mean? And I guess this is the most exciting field for any software inclined person. Then evolving a bit slowly initially, but eventually we expect to be a major player is the non-terrestrial networks. So your satellite communication and reconfiguration, reconfigurable intelligent surfaces are really, taking this beyond just telecom equipment and, you know, in our general infrastructure all over the world, usage of materials that actually help propagation and improve overall transmission and reduce losses. So I think those kind of surfaces are called reconfigurable intelligent surfaces. I think that is also a very interesting topic. So we'll get into it. The first one is the convergence of the communication and computing world. So as you can see, the computing power in a mobile phone is much lower than in a PC. And to render some of the future services, like for example, take hologram, there's no way it's going to be possible just within the UE. So what it means is we need to make possible a scenario where computation would be shared in the mobile phone and also in the network to deliver any kind of end service, for example, a hologram. Obviously, you have when you have lower latency, high data rates as expected in 6G, this can be possible. Yeah, because they need to the devices and the networks need to synchronize more often, right, to make this kind of communication possible. So what it means effectively is the power of computation is going to be much greater than the power of communication, and that needs to be leveraged to deliver the 6G world services. We'll talk about comprehensive AI now. So, AI has started finding its way into individual components of a telecommunication network. You may have seen some of our new mobile phones which come with, Galaxy AI integrated and some cool Google features like circling and identifying, right? I'm sure you would have seen that. So those are all local artificial intelligence in the UE. Similarly, there are AI applications built into the base station and core network, especially for things like energy saving. An application world anyway has a lot of AI. So they work mostly independently at the moment. Maybe some joint interaction is happening. But in the 6G world, we would actually have embedded AI technology from the beginning of system design so that we get an end-to-end experience. So whether it is network planning, prediction, detection, network management, automatically detect a problem in the network and fix it, and or in general improving the performance of the network system, learning based on LLMs and history data. So I think all those will be built in from the design phase itself. So as a design principle, we'd have a communication system plus AI engine integrate right from the design phase. Unlike, 5G where the AI engine is typically built on top of the communication system. So I think that's fairly easy to understand, of course, and a very vast topic and very exciting topic for all of us to look at in the coming years. It's already started. Then there is the non-terrestrial networks, which basically means integration of satellites into traditional cellular networks. So, there are different kind of satellites. There are the LEO satellites, which are the low Earth orbit satellites with typically latency of 2 to 27 milliseconds. And we have the medium Earth orbit satellites with even lower latency, and then, of course, the geostationary satellites. And they all operate in different frequency bands. So, how can we bring all of this together? Satellites in different layers, multi-tier hierarchical network interacting with each other. Will have the LEO satellites maybe working with balloons or high altitude platform systems, or flying base stations, which may be more in the stratospheric layer or aeronautical layer, right? So all this is gaining a lot of prominence. We have already Starlink. I'm sure you've heard of Starlink, right? So I think Elon Musk is making this a reality, right? And we have satellite companies already making inroads into 3GPP. So we have released 17 non-terrestrial network work items already, and I'm sure this area will evolve a lot. So we are not looking too much into it at the moment from a Samsung point of view, but at some point I'm sure we will get into it as well. So next is the RIS, or the reconfigurable intelligent services. See, it's one of the key innovations which facilitates the management of radio environments. So RISs are envisioned to be configurable. They can divert, alter multiple waves, across line of sight simultaneously, and have very low energy footprint. So these make the environment a freely configurable and tailored, rather than an unpredictable entity as seen today. It was almost like engineering the environment to make communication easier. It was a really hot field. I do not know too much in depth about it, but I do know that this is, among all the 6G technologies, is one of the most exciting areas of research. All right. So, as we move ahead on the path to 6G, we can see a lot of push from governments around the world. And in fact, a lot of public sector and private sector partnerships evolving all over the world. We have, for instance, the Next G, or the NSF in North America. We have the 6G SNS and Hexa in Europe. And even in India, I think if you've been following the news earlier this year, there was this grand announcement by our Prime Minister on the Bharat 6G alliance. A lot of people jumping on board there, wanting to collaborate. Many top tier institutes receiving grants, um, IITs, maybe some NITs as well, and co-working with many private sector companies as well. Um, we are not officially part of this, but yeah, we are engaging with some universities internationally to further this research. Yeah, so this is going to be a cornerstone of progress towards 6G, and we obviously expect global forums like the ITUR to define clearly the charter in the path towards 6G. Yeah. All right. So I'm more or less at the end of my short presentation. I think as we move towards this hyper-connected world, I think there are three things that are very important and to be kept in mind. Number one, we need to start early because it's a decade-long journey, and in fact, we have started. So I think it's already 3, 4 years since the first 6G research commenced, and I think we have all players getting into it. And I'm sure just as the world came together to finalize 5G, we'll do the same with 6G. There are many candidate technologies. We discussed comprehensive AI. We spoke about split computing. We spoke about RIS. We spoke about non-terrestrial networks. There are many other things as well, tactile internet or metamaterial. So all these will need to come together. And I think bright minds like you have, a lot of choice to choose and focus on. And I think the key is enhanced capabilities through AI and sensing. So AI and sensing getting integrated into communication. So communication will no longer will be just communication as we know it and we study it. No more just protocols. So I'm sure it will evolve into something much more interesting with a lot more spice, and that should help in the evolution path towards 6G. So, guys, that's what I had today. I'm, of course, open to questions. Again, disclaimer, I will do my best to clarify your points, but may not know everything. Yeah.
Good evening, sir. Sir, before wrapping up, we'd like to have a short Q&A session with you, if you're fine by it.
Yes, sure, sure.
Sure, thank you, sir. So, starting off, sir, what inspired you to pursue a career in telecommunication, and what challenges did you face along the way?
Oh, that's a great question. So yeah, I'm a real oldie in this domain. I think in another 6 months I'll complete 3 decades, right? So when I graduated way back in 1995, um, I think communication and internet, these were the two hot domains. And mobile communication was just starting, so it was naturally an attractive technology field to get involved in. Um, so that's what lured me towards this domain. And challenges, yeah, okay, sure. There were a lot of challenges. So, as we progressed, there were ups and downs, right? I don't know if you have heard of the curse of the odd generation. So, 2G, the first real mobile communication technology, was a huge success, right? So, we all enjoyed that success and we were expecting something, you know, if not bigger, at least as big in 3G. But honestly, 3G was a flop, right? So, there was a big kind of a downside in the telecommunication industry. I remember those years, especially, I think maybe 2005 to 2010, maybe that kind of zone when we were struggling. We were struggling quite a bit. And there were many times when I thought, hey, did I do the right thing coming into this domain? But fortunately, 4G happened because 3G had a very short life, right? And 4G, again, it was a roaring success. And today it's really the dominant communication technology, and that sustained us for another 10, 15 years. So I think there will be ups and downs in this industry. But let me tell you, it is an extremely enriching experience. The very fact that your work is going into the backbone of multiple countries, right? Telecom infrastructure is actually the backbone of all countries. So your work directly, impacts a nation's backbone. And for instance, solutions which I've personally worked on today are working or deployed in almost 30 countries. So that is so satisfying that it doesn't matter if there are, some momentary years of slowdown in the industry. So that's what keeps me going. Yeah.
Sir, what advice would you give to the aspiring telecommunication engineers about entering the industry today? Like, what skills should they focus on, sir?
Again, a very, very good question. I think I summarized it in one of my slides. So, telecommunications is no longer just communication, it's convergence of computing and communication. So, while you got to have your fundamentals thorough, by fundamentals, I mean all your fundas in protocols, in digital signal processing, and so on, which are the heart of the telecommunication domain. I think you need to really strengthen your software skills as well. So it is almost a 50-50 game now. So I think this decade, software and software or computing and communication, both skills are going to be equally important. The good news, of course, is that to us Indians, software comes very naturally, and we are world renowned for it. That's why Indians are holding the top level corporate positions in so many multinational giants, right? So I think we are naturally tuned to this. So it's just that don't forget, you got to be good programmers as well, apart from understanding the basics.
How have major projects like Geo's launch and 5G deployment in US and South Korea shaped your career and your perspective?
Okay, so like I mentioned, it's like career altering or career defining moments, honestly. I still remember way back in 2016, we used to travel every month to Mumbai, uh, to the RCP office in Navi Mumbai, right? That's where Jio's office was set up. At that time, their network had just 50 pilot users, the network which we had set up for them. 50, 50. And now, it's one of the world's largest telecommunication networks. Uh, the way they redefined even basic tariff handling by giving voice for free. I mean, that changed completely the way we lead our lives, right? So to be a part of that journey was simply like I said, a career defining moment. So Geo launch was huge. 5G was again big because there it took our scope of influence beyond just India, right? So we were part of the team that launched the first 5G networks in Korea, in US, and in Japan, and just to have that feeling of that we had graduated one generation from 4G to 5G and how fast we could do things. That was again very, very fulfilling. I think anything where, any product that we develop, most of the products you will find you will be developing partly, you'll do some small part. You sometimes don't know how it fits into the big picture. But fortunately, in my career, I had these two, three opportunities where we were part of a complete end-to-end product development. So that was really very, very satisfying, and it helped, of course, my career to grow as well.
Sir, as a head of R&D at Samsung, how do you prioritize new technologies and research areas?
Okay, this is a classical dilemma, right? So, telecommunication business is not easy, right? See, if you are building a product for the user, like a user appliance, even a mobile phone, um, it's a little easier because the user will tolerate certain defects, right? There may be a crash once in a while, and you just restart your phone, or some app hangs or something like that, right? But the tolerance level in the kind of telecom infrastructure business is very, very low. So it must almost be perfect. So to achieve that kind of quality requires really uh, a lot of effort. Therefore, what happens is, a good amount of our time goes in solving current problems, right? We've deployed a network somewhere, there will be problems coming from that. We have to quickly respond, and that sucks up most of our R&D bandwidth, right? So the challenge is how to put aside some percentage, yeah, 5, 10, 15% of our time to devote it to research and innovation. So this has been a journey that took me in my organization at least, a good 5 to 6 years. I remember when our team started, the network team here at Samsung R&D was just about 100 people 10 years ago. Now we are almost 700. And I think for the first 5 6 years we did not even have a single patent to our credit. Yeah, we would see around us other businesses happily finding time to innovate and prioritize even the innovation. So I think we had to build a culture of innovation while we are busy solving the current problems, right? And this journey, maybe it started in 2018. I think now we are at a good level. We are able to dedicate 10 to 15% of our bandwidth. We are able to inculcate a sense of a culture of innovation among people so that they, by default, reserve some amount of their time to innovate. You cannot innovate at gunpoint, right? You have to instill it in the culture. So yeah, that is how we gradually began prioritizing innovation for the future, and I think we are on the right path at the moment.
So, how do you envision the future of Internet of Things or IoT, and what opportunities does it present for innovation?
Okay, good question. Actually, IoT, has been around for a long time, and it did not become as big a success as we expected it to. So it's been there initially, even, and of course there are two categories, right? There is IoT in cellular communication, right? Which the normal cellular communication reserves certain frequencies to facilitate IoT, certain equipment, certain networks to facilitate IoT, and then there is a totally independent set of non-cellular networks also, which can provide IoT. Yeah. So for long, anyway, the non-cellular networks have been in place for a long time. I mean, you have IoT uh, installations in many enterprises, right? You may have it in a factory for factory automation or for fleet tracking, but that may not be integrated with your mainstream cellular network. So mainstream cellular network share of IoT is still just 20%. Okay. And this is mainly with 4G, to some extent with 5G. We expect this to grow many-fold with 6G. We expect larger densification of the IoT sensors. You will see it in more and more places. It will take still some time, but definitely in the last 10 years, it has picked up. Yeah. So I would say lukewarm, maybe last 5 to 10 years. Now picking up more in the 5G era, but the real big burst will come, I think, in the next maybe 5 to 10 years.
Sir, what advice would you give students for handling their setbacks and building resilience in their academic and professional journeys?
So this is a very deep question, actually. Uh, you know, um, we hire so many bright minds every year from campuses, right? And they're obviously the best and the brightest. We go to the top institutes like yours. Uh, but once you enter the corporate world, see, academic world, you have your own challenges. I've been out of that for almost 30 years now, so I may not be able to relate. Uh, Back then in the 90s, I mean, engineering college was honestly quite quite comfortable. I think I'm sure it's a lot more competitive right now because you guys have to. First of all, the numbers are so much more in our country, and everybody is good and everybody wants to excel, right? But when you enter a corporate world, it becomes the ball game will change. You picked up some skills, right, in your college and your academics. Yes, those skills are important, but only 50% or maybe 40%. What additionally is important is for you to continuously learn and continuously innovate. Don't think that, you completed your degree, you got a fat pay package in some IT company, and that's it, you're set for life. The grind will start again, right? So I think you guys need to be mentally strong, you need to be mentally mature, and you need to accept also your limitations and learn to balance your work and life. I would give equal importance to all these things, right? So I think overall mental health and well-being is a big topic now in corporate world, especially among young people, right? Because sometimes they're just so used to being on the top, doing well in academics. When they realize the game changes in corporate world, accepting even a small failure becomes a problem. But you will face failure, and you must learn to toughen your mind to learn from it, to accept it, to be humble, and come out stronger, right? So it's something you guys should prioritize over everything else. Honestly, I think you'll need it.
So, can you share an exciting project from your career that could inspire us students?
Yeah, I think Geo launch definitely. Geo, we spent a couple of years there. So the thing was, the base solution was already done in Korea, right? So we kind of just fine tuned it and then took care of the problems from the deployment. We were more like a technical assistance center than a core R&D. So even though it was euphoric to be associated with Geo launch, I think the true satisfaction comes where something you have built, you coded and you delivered, and that is running somewhere. So for that, I think I would probably say the first exciting project was a project called EMTC. I hope you guys have heard of EMTC. It is basically the person who asked about IoT may know. I mean, it's basically wideband IoT, right? So in a 4G network, that entire task was given to us to implement the EMTC stack from scratch, implement, deliver, deploy, right, for customers in India and in the US. So I think that was such a kind of a learning experience because we were like doing endless night outs and there were so many problems, and by the time it was done, like we were all totally and physically, mentally exhausted, right? So I think that was an amazing experience when we saw that software running out there in the network, connecting your IoT devices, right? I think that was really very satisfying as well.
Sir, are there any books or online courses or resources would you recommend for the students who want to excel in the advanced communication?
Oh man, I honestly, book reading I have left long back. I usually just read articles off the internet. I just subscribe to a lot of these telecom business articles. So I haven't been reading for a long time. I'm the wrong guy for that, but I can. I have got some really solid PhD grads in my team. I can find out from them and I can share with you guys. Yeah.
Thank you.
If anyone from the audience has any questions, they can post it in the chat box. Chat box is open.
Okay, so yeah, so I don't think coding as such has started for 60, but it's more like, prototypes, right? So, our business traditionally has been running mostly on C, C++, the wireless network elements. However, the AI layers and the management layer, of course, uses Java or Python or even Golang, right? And we are experimenting with Rust as well for embedded because it's supposed to give you some gains. But the code is so complex and already written, we are hesitant to migrate it to a new language, right? But 60 would be a bright start, so maybe even Rust, right? But for sure, I think C may not die out, C, C++, and definitely Java for your management and your orchestration layers, Python and Golang for your AI layers. So basically, there's something for everyone. Whichever language you enjoy, you can come and get a share of the pie. Yeah. Yeah. I wish I had wasted less time in, I mean, I'm not saying that I regret having enjoyed my college life in other ways than academics, but I think a little more focus during the college days may have actually helped to build a stronger corporate career. But I think the parameters are totally different. I think what nowadays maybe you guys are doing things by default. I heard that in many of your institutes there are some guys running startups already, right? So I think the game has totally changed. So basically, don't waste any time. I think yeah, have your fun and set aside some time for whatever your passion is, whether it is reading or building something on your own, completely independent of the curriculum. Yeah. So don't waste that even 1 hour every day, like I did. Yeah, it's really tough. Um, one great way is to actually do things what I'm doing now with you guys, right? So I had a very busy schedule in the last couple of weeks, but I deliberately said yes to this opportunity because it helped me to again revisit some of the literature which I had may have read some couple of years back. Um, just reading through it again kind of refreshes my memory and helps me to keep in touch, right? So I think um, interacting with academia is for a guy in corporate, right? Because we get so tired by the regular corporate drill. Any opportunity to interact with academia or even something totally different like government, regulatory bodies in government and just touching base with them. The government world is another, complex maze. So this kind of things, basically you need some variety. Yeah, otherwise, in your daily corporate grind, you're going to get tired, right? So I keep pushing myself to seek out such opportunities for interactions with outside industry forums uh, to keep myself motivated. Right.
Any questions from the audience? Right, sir. Thank you, sir. Your lecture was truly enlightening, offering us a dive deep into the future of wireless communication. And we, along with you, sir, are excited to see what the future holds. We are grateful for your answers to our questions and for offering us guidance and your valuable insights. Your words inspire us and will definitely be motivating for those looking to explore research, development, and telecommunication. On behalf of ECE Association, I would like to once again extend our heartfelt gratitude to Mr. Amit Mannan for taking time out of his busy schedule to speak with us today and to mentor the next generation of innovators. This is Naman from ECE Association signing off.
Thank you. Thank you, guys. Pleasure. Pleasure is all mine. Thank you. Bye.